Hi, and thank you for attending our session. My name is Fortil, and with me today is Xiaoming Wang. We are both from the platform team, which is the platform that develops the HPCC Systems platform. And our daily job mainly focuses on making your life easier as users of the platform. Since our first release of the cloud native platform, we have dedicated a lot of time and resources to develop new tools to simplify the way that you deploy the platform in the cloud. In addition to our command line tools, we have now 2 new ways to deploy the platform. Please be aware that this presentation is geared toward our community users. And if you are an internal user, please consult with the Cloud Business Office for internal use. So during this presentation, we are going to talk about how to deploy the HPCC Systems Cloud Native Platform in Azure using Terraform, how to deploy the HPCC Systems Cloud Native Platform in Azure using Flux 2, and an existing Kubernetes cluster which you can also deploy with Terraform. And then lastly, we will discuss pod placement. For this exercise, you will first need a code editor, such as Visual Studio Code, Git, kubectl, Azure CLI, and Terraform. We have 2 new modules. The first module is the storage module. The storage module creates a storage account, and that module must be deployed before the AKS module. In case you already have an existing storage account, this module is not needed. Next, the AKS module. The AKS module creates an AKS cluster. It deploys the HPCC systems and must be deployed after the storage module if you want to create a new storage account. Again, in case you already have an existing storage account, the storage module is not needed. If you look on the right side, that's a screenshot of the AKS module and all the files within this module. We have the admin.cf file, which is the file that you are going to be to work with in order to configure the cluster. So how to deploy the storage and the AKS modules? First, you will clone the Git repository. You will create your personalized admin.cf file. Next, you will initialize the module. And then lastly, you will deploy in Azure through a Terraform apply. So let's take a look into the admin.cf file and see and go through some of the options or arguments that we have in that file. The first block you might notice once you open that file is the admin block. This block is responsible to create tags based on the name of the user that is deploying the platform, and also the email of the user in order for to create an email tag in case that was in case someone wants to contact that user. And other blocks are the resource group block and the metadata block, as you can see. So another block is the node pools block. Inside that block, we have the system node pool block, which is responsible to host the system node pools. and also the additional node pool blocks, which are responsible to create the user node pools. Next, we have the HPCC block, which which deploys the HPCC Systems platform. And after that, we have the storage block, which linked the storage account to the cluster. And for that block, you will need the storage account name, resource group name. If the storage account is on a different subscription, else than the subscription that the AKS cluster is, you will also need to pass the subscription ID of the storage account. And all of that information will be pointed out once you deploy the storage module. And after the storage account, we have the ELK block, which deploys the ELK for the HPCC Systems platform. And once you deploy the platform, at the end of the deployment, you will get that information pointed out. First, for the storage account, you have the location, the resource group name, the storage account name, and the subscription ID of the storage account. And for the AKS module, we also have the recommendations that are printed out at the end of your deployment. But keep aware that this list takes a few minutes to be populated by Azure. So at the first iteration of your deployment, you might not have anything in this list. One thing you can do afterwards is do a Terraform show after a few minutes, and you should get feedback from Azure whether you have some recommendations based on your deployment. So to deploy the AKS module, you just do a Terraform apply and you pass the admin.cf file as a variable file. Next, we will be talking about how to deploy the platform using Flux 2. And for that, I will switch over to Xiaoming Wang, who is going to talk to you about how to deploy the platform using Flux 2 on an existing Kubernetes cluster.
Godson just talked about how to use the Terraform to deploy the AKS and also deploy HPCC. I will talk about if you already have an existing Kubernetes cluster, you can use the Flux 2. Well, the HPCC actually provides a simple way to use the Helm chart. You can deploy HPCC. I'm talking about use the Flux. Actually, it will give you a version control for your deployment. So what is Flux? Flux is a tool for keeping Kubernetes cluster in sync with the sources of configurations like Git repositories, and automating the updates to configuration when there is a change. So Flux 2 is just the version, so Flux version 2. Here is the reference for the documentation. For installations, there's a prerequisite for the Kubernetes server 1.16 and later. And also for the client, its Kubernetes control should be the 1.18 and later. So to install the Flux, there is the link for the installation. Basically on Linux, you just run the curl to download the install script and then use the bash to install it. After that, you need to make sure you have a Kubernetes cluster ready and then check it is to satisfy all the requirements. So you run the command the Flux check with the parameter prerequisite. Yeah. For the Flux tool on Azure, there is a recommendation from the Flux tools. Basically, there's some network settings. At least in the right and the left side, there's 3 settings. Usually recommended by the Flux documentations. And you can read more about the link. Now, for our exercise, we provide a sample repo that in the GitHub, and the link is the repo name is called flex2-HPC cluster. Basically, this repo have a file structure. I mean, the tree structure in the right. At least here it's there totally is 4 top-level directories. At least 3 here, and the next one will list in the next page. Basically, the bin directory have some help scripts, and the cluster directories have really the top level of the deployment files. Under the cluster, you can see I have a dev. Actually, you can have a multiple directory here. For example, you have a testing, you have a production, or some other one you want. And under that dev directory, I have a Azure and the local, because I only test the Azure and the local. But this Flex2, you can deploy in all the major cloud provider environment. So the next one folder is the infrastructure. That basically will have all the resource, either the GitHub or the Helm chart information, and also some third-party application you want to integrate it with your applications. So go back to the middle, the cluster dev Azure. When you deploy, actually you're looking for the file called app.yaml. At least in the middle, what is the app.yaml looks like? Basically, there's 3 things. One is the dependency. So that's dependent on the infrastructure, the directory. And also there's a Flex systems that actually will inject by the Flex. So you don't need to worry about that one. And then the third one is the important one is what you really want to deploy for your deployment. That is the path, is the app, dev, and Azure. That we'll talk about next page. So the app is the last directories in our tree. So at the right side, you will see as all the apps have several directories. The base one is mainly to define your statics, the deployed applications. In our case, we have Elastic that basically for our logging. And then there's HPCC, that's a major for the HPCC platform cloud applications. And then we do have Ingress, and then we have storage for the either Azure or local. Below is the dev, that is what we really want to deploy. So in the previous page, we say we point our path to the app dev Azure. So if you look at here, the dev Azure, there's a file called the customization.yaml. So every time you give a directory, the Flex, we're looking for this customization.yaml file. So at least in the middle up graph, what it looks like. Basically, that will define what you try to deploy. So we have the base storage Azure, and then we have a base HPCC, and then we have Elastic, we have an Ingress controller, and then also the Ingress itself, the definitions. And then on this graph, the next part is called a patch strategical merge. That actually you can modify your configurations, your list above. So basically we have 2. One is the storage, another one is the HPC itself. So on the bottom of the middle graph, I show what is on the bottom of this middle graph, I show what is the customization YAML file for the HPC. So basically that will point to our GitHub repo of the Helm chart of the HPC. So you can define the name, you can define what's the interval you want to look at the update, and then how many times you want to try if it's failed. And on the left side, that is how we want to modify our configuration before you really take off the deployment. So usually you will update the HPC values, the YAML file. So here we pointed, what we define here is the first is the image version about the Docker image, and then what you want to modify the YAML, the values of YAML file. So here we set the old ESP services to the external IP. Now on the bottom, I comment out some the code post renderers that actually from a Helm command. So this one gives you a handy way if you want to modify any settings that are not controlled by current HPC Helm chart. So you can add in here that can modify your runtime YAML file for your HPC applications. So with all the repo we talk about, so when the flags to communicate with your repo, you need to give a token. So you need to create a personal access token for your repo. And also you need to define the several environment variables. So we provide an env file in the bin directory that defines the 3 environment variables. Particularly one is your token, what you have. On the right side at the top, we provide a helper script called flags sh. So basically that will define how you want to start your the application. So the command is flags, bootstrap, and GitHub. So here we have owner, repositories, and the branch. So what branch you want to deploy, and then the token and some network setting. And particularly the last one is the path. That is pointing to what we talked about before is your cluster dev Azure. And then when you try to start, you just run the script, or you can run manually through the flags bootstrap GitHub command. So here is what it looks like when you start your deployment. So the flags get all will show all your components. The first, the red block is show you the GitHub project repos, and the middle orange one is the Helm chart, and then the blue one will show how many Helm chart, this application start from a Helm install application. And the last one is the top level of the customization we defined in the flags files. You can read more about the flags command with the flags help. And also at the bottom, at least the Helm manage the application you start. Oh, just remember, we use by default, we use the HPCC system namespace, but you can change it to the other namespace as well. So after you start, your deployment, you can manage your cloud just through the normal GitHub process, such as you check out your repo and you can update, add, commit, do the pull request, review, merge, and rollback, etc. Also, I only showed one deployment for the dev. Actually, you can have a multiple deployment. So you can have a dev, a test, a production, or even you have a blue or green if you want. You don't need to just start the new Kubernetes. Basically, you don't need to switch the context, but the flags command have a context parameters you can switch through there. So to clean up, you just run the command we provide a helper script called flags delete. Basically, you will see it will uninstall the namespace under the flags system, and then also the HPC system, and then we delete some persistent volume and also some other resources we created during the deployment. Okay, so next topic, I will talk about the part placement. This probably will need it when you have a, for example, case for the part instance, the node pools. So all of this is related to the Kubernetes scheduling. There are 4 categories we supported now. One is the node selectors that will decide the node, which node can run on which part can run on which node. The node selector is the field of a part spec. It specifies a map of a key value. The nodes have each of the indicated key value pairs, the labels. So you can create a node label zeroing after the node pool creation. And also the next one is intent and toleration. That work together to ensure that the pod are not scheduled on the inappropriate nodes. One more thing are applied to a node. This marks that nodes should not be accepted any parts that are not tolerant that can. Again, you can create intents and during after the node pool creations. The next is the affinity and anti-affinities. which just extend the type of constraints like the node selectors. It includes two types of affinities, node affinity and also the interpart affinity and anti-affinities. You can reference top link for more details. The scheduler profile is just a scheduler allow you to configure different stage of the Kubernetes scheduling. It includes all the above and other items. So here is our format of HPC supported. You can reference the file called placement.md. Basically, you first define which part you want to have this definition. And then the real placement, you can have a node selector, you can have tolerance, affinity, and or the scheduler name, the files. Here I give an example. So for example, you have 3 node pools. One is the system, and the other is the user and normal user node pool, and also you have a Spark node pools. So for the part placement, first you want to have a definition for all. So you will allow the old HPC part can be assigned to the Spark instance. And then we want to restrict Darty and Sasha only to the middle node pool. So you will have a tolerance to that node pool. And also you want to add the node selector. So this way you can enforce that Darty and Sasha go to that middle node pools. Okay, that's all the topics we are covered today. And we have a reference, so Terraform and also Flex2 and our contact email address. And thank you everybody to attend our sessions. And if there are any questions, we can answer. Thank you.